So there's been a flurry of announcements by Elon Musk, specifically around subject of AI. First and foremost, he's saying that Colossus 2, built by XAI, his company, will be the world's first gigawatt plus AI training supercomputer. And here comes the interesting bit. He goes, it has a non-trivial chance of achieving AGI. XAI is close to having all the pieces in place. Now, of course, we got to understand that AGI isn't precisely defined, so it's kind of hard to know what everybody means when they use the term. Now, let's define AGI for the time being as the point at which all of us are arguing whether or not we've achieved AGI. So when a lot of people are saying, and this is obviously AGI, and another large group of people are saying, no, we're not there yet, then maybe that's AGI, the arguments we've had along the way. If you have a better definition, tell me, but for now, let's go with that. It's when enough people say it's AGI. But today, let's talk about what are all the pieces that need to be in place to achieve AGI. What is he talking about here? Well, one way of looking at it is having the AI models, the compute, such as the Colossus 2 gigawatt cluster, having enough electricity to power it all. And Elon has been rapidly acquiring, access to electricity, including shipping entire power plants from overseas. Now, there's been a lot of discussion on how good the current GROK model is. Some people are saying it's not as good as everyone else's. Some people are saying it's exceptionally good. Here are some important things to understand about GROK 4. There are a number of things that GROK really excels at. So first and foremost, GROK 4 is still number one at live code bench. So as you can see here, this is the chart. This is GPT-5. This is GROK 4, Gemini 2.5 Pro. From the testing that I've done and also a lot of the feedback kind of from the community, it seems that GROK 4 might not be the best for smaller tasks, but it seems to excel at some of the more difficult long tasks. It tends to code at length. It tends to approach everything as if it's a hard problem. It might be a little bit slower for some things, but there's a reason that some people for their projects that are a little bit more complicated tend to use it quite a bit. Here's Denny Lamancetta cranking out games using pretty much GROK exclusively. They're cranking out game UI design with GROK Imagine, and he teamed up with Max Herden, I believe. I spoke with this person through DMs. We might be hopefully having an interview with him soon. I'm very curious how they're building these games, because the games are looking pretty good. Neither one of them, Max or Danny, as they say, neither of us can code. So they're doing a vibe coding sort of process. And I gotta say, I'm kind of impressed with the results. So we'll dig deeper in why they're choosing GROK over Gemini 2.5 Pro, over GPT-5, all the other models. You may have followed the saga with Theo, who's a developer, came out with some pretty strong, very positive initial reviews of GPT-5 before it was released, and later kind of ran into some issues with it post-release. So he's kind of trying to unpack what went wrong. My personal take has been from the beginning is that GPT-5, if you're able to tap in like the best of the best models into the very powerful models, those are really good, right? So at its best, it's really good. But the model picker, the routing to which model goes to, there's a lot of issues with GPT-5 that I got to say that went wrong. When it's good, it's freaking good. It's just hard to tap into that consistently. But the point is that Theo here talks about GROK 4. So you're saying, like, if we go to Open Router, look at my favorite model, GROK 4, you'll see we're one of the top users of GROK 4. Here's the really important part to understand. So this is, again, not my words. This is Theo. I'm pointing out because it does line up quite a bit with my experiences. As you can see here, we've all seen the benchmarks for GROK 4. It's one of the smartest models ever made. It regularly outperforms almost everything else on every benchmark. It's clearly one of the smartest models ever made, and he avoids using it entirely. Not just because it's super expensive, not just because it's super slow. The issue is that it tries to 200 IQ everything, meaning it tries to throw everything at even some of the simpler problems that maybe don't need that level of thinking. So don't be surprised when you see GROK 4 at the top of, a lot of benchmarks, seemingly really, really good, and yet not the number one go-to model for everybody. It's not because of its lack of ability. There's just some optimizations, some polishing. If you look across a lot of the top models, best in reasoning, GROK is there. GROK is near the top in AIME 2025. It's number one on the SWE bench, which is the software engineering benchmarks. So it's 75, runner-up is 74.9. So they're all roughly equal, but it is slightly ahead. By the way, on the AI Meet 25, GROK 4 Heavy with Python, 100%, right? So it just completely nailed everything on the exam. And here I was trying to find a chart that showed GPT-5 and GROK 4 in the same chart. For some reason, I couldn't find it in the moment. But as they say here, GPT-5 performs well on ArcAGI, but GROK 4 remains state-of-the-art on the more complex ArcAGI 2. I believe it was Greg Kamrad that said, so he's one of the, I believe he's the president of the ArcAGI Foundation Prize. He mentioned that GROK 4 shows non-zero fluid intelligence. So if you think about fluid intelligence versus crystallized intelligence, crystallized is like learning from your experience and then applying that experience to solving the problems. Large language models, that's kind of what they have, right? So if they have something in their training data, they're likely going to perform well on tasks that are required to use that data, their quote unquote experience to solve a task. They've never been that good with fluid intelligence. So, figuring out how to do a task or a new challenge, a new problem that you haven't seen a lot of examples of in the past. That's fluid intelligence for humans that peaks in early adulthood. Generally, older people with a lot of experience, they rely on sort of crystallized intelligence, while younger people have a lot more fluid intelligence to be able to learn faster, acquire more experience, etc. Now, why is this happening? What's happening behind the scenes? Well, there's this little interesting chart. This was a talk by OpenAI at the Sequoia Capital Summit. So they're saying how initially we were training these models, just giving it pre-trained compute. So the kind of the hardware that we used to train them, it was all went towards pre-training. Then with the first reasoning models, some of that went to RL compute, or maybe it was added on top. You can think of it as a cherry on top of the cake. Right, so we started also doing reinforcement learning, throwing reinforcement learning compute at those models. And specifically, this kind of illustrates what happens as we scale up that reinforcement learning compute. OpenAI believe, and a lot of other people believe as well, that this is kind of like the next big wave of AI progress. Now, Andrej Karpathy actually had a great illustration of how to think about pre-training compute versus, reinforcement learning with human feedback versus RL, reinforcement learning. And he compared it to like when you're studying for a class, let's say it's a math class in college, university, whatever, sort of reading the chapters of the textbook, that's your pre-training. You're just reading the information and trying to memorize as much of it as possible, right? So you just read, memorize, and also kind of form these concepts, kind of compress information so you understand the concepts. So it's not exactly necessarily memorization. It's more like just trying to get all that knowledge and data somehow packed into your head, whether through memorization or just understanding the concepts. That's pre-training. That's what GPT-4 was, GPT-4o, etc. Now, most models are also trained after that with reinforcement learning of human feedback, RLHF. So Andrej Karpathy compares that to, if you ever seen those problems, once you're finished with the chapter, let's say they have math problems and they show you step by step how to solve them, right? So they give you the problem and they're like, this is how I did it. And they walk you through how to solve it. So it's kind of like demonstrating to you how to do it. And so let's say the model or the student tries to do it. And, if they do it in the same way, we go, good job. And then you also have just the problems that are probably at the end of the chapter. And usually you have the answers maybe in the back of the book, so you can look up if you did it correctly or not. But that can be thought of as RL, right? So you do a problem and then you either pass or fail it, and you just do a lot of those problems. Over time, you get better at doing those problems. You come up with certain shortcuts, certain cognitive strategies for solving those problems. And so a lot of people believe that the next big wave of AI progress will come from scaling up RL. So making those models that have, read all the textbooks in the world, let's not just give them a bunch of problems to solve, right? So you can think of it as almost running them through simulations or just running through a bunch of problems, but that takes its own compute. And you can think of it as almost like an RL gym where we train them to do certain specific tasks, like to be better at coding or to be better at math, etc. So GROK 2 to GROK 3, we had 10x compute, specifically the pre-training compute, right? So reading the chapters and trying to understand the information. GROK 3 with reasoning was that plus this, cherry on top of the cake to get it to be able to reason. They don't specify how much more, but maybe a tenth of that compute went towards that. So what is GROK 4? GROK 4 is a reasoning model. So did we 10x the pre-training compute? Is that where that power comes from? No. We 10x'd the RL compute, right? So it just doing a billion different problems and trying to get better, right? So testing things out, seeing what works. If it gets the answer right, gets a little high five, and it learns, okay, this is the approach that I need to be using to make that happen. GROK 4 is basically GROK 3 with 10x the amount of compute thrown at it. I love this post on Reddit, on the subreddit Singularity. It says, so GROK 4 is just GROK 3 with more RL? Yeah, it would certainly seem that way. So this person says, so you want me to tell me that all the existing models can be pushed way farther in terms of performance with reinforcement learning? Yeah, so there's some confusion about what like the high models mean. That's not the same as reinforcement learning. That's giving it more time to think. So that's the test time compute. And this is kind of the important thing to realize when people say, you know, the scaling laws are coming to an end, that we can't just keep scaling these models anymore. You know, throwing more pre-training compute at it, it's exponentially more expensive for the same progress. So yeah, that's going to get harder. So if you spend a billion on getting the latest compute, the latest chips, right? If you need to 10x that, that's 10 billion. 10x it again, that's 100 billion. It rapidly gets very expensive, very prohibitive. But we were also able to scale with test time compute. So by giving it more time to think before it answers, and that worked well. Again, this is the ARC AGI, the first one. So as you can see here, O1 low, O1 medium, O1 high. So you can see when we give it more time to think, it gets better, right? There's going to be some diminishing returns somewhere, but we are able to scale it with test time compute. Same thing here, O3 mini low, medium, high. So these dashed lines are the test time compute. We're scaling up test time compute. But GROK 4, I think, is hinting at the wave, at the next sort of S-curve or exponential curve, however you want to think about it, that's coming next. And that is just scaling up reinforcement learning. So if GROK 4, which again is sitting at the top of a lot of charts, a lot of benchmarks, people are saying it is, in certain ways, the smartest model currently available. That model seems to be GROK 3, right? Kind of like that old model, right? But with tons of RL compute thrown at it. So this begs the question, what happens when we either do even more RL compute or perhaps, you know, create a bigger base model, right? So in other words, take this white line, the pre-training compute, increase that, and then put the 10x RL compute on top of that. What does that look like? So this is the visualcapitalist.com. They have really good charts. Often, surprisingly, they do just a great way of visualizing this information oftentimes. So if you think about it at a glance, who do you think is likely to take advantage of this new scaling law, if you will? Who's going to be able to throw the most RL compute at these models to see how far they can scale it with that? By the way, we've covered Absolute Zero Reasoner as well as DeepSeek R10. So a lot of these are also pointing to the fact that reinforcement learning can potentially be scaled to pretty staggering new heights by taking lessons from some of the older Google DeepMind technologies, such as what they did with AlphaGo, AlphaZero. So imagine in our original example of where you're sitting there and, you know, going through the textbook, reading the textbook and solving the problems at the end. This would be more like if we made two clones of you, or maybe a lot more clones of you, one being the student and one being sort of the problem proposer, or maybe you can think of it as the teacher. And the teacher's goal would be, again, that's still you. It's the same sort of model doing this. It's engaging in self-play, right? Similar to how you can play chess against yourself. You're the teacher, you're the student, but you as the teacher, you're dreaming up new problems to propose to yourself, your student version, that will improve your own abilities to do all sorts of other problems, right? So you improve your abilities at coding or math, etc. So the teacher model, as it's doing it, it's getting better at teaching itself, its own version, right, at how to understand these problems. And the student is learning how to do these problems based on the problems that the teacher is giving it, right? So the model learns how to solve problems entirely through self-play. So kind of coming back to this chart, so keep in mind that the biggest ones are sort of in the center. This is XAI Colossus phase 1. So this is what they've been using to train a lot of the models that we're talking about right now. It's equivalent to Microsoft and therefore OpenAI. Meta AI looks like is right here as well. By the way, Tesla is its own separate bubble here. I'd be very curious to know how this compares to Google's TPUs. And Google also has, you know, GPUs from NVIDIA as well. But the point is, this is XAI Colossus phase 2. And this is the thing that's going to be training the next generation of models. They're saying that GROK 5 will start training this year. XAI, of course, also has the voice model, the image generation model, the video generation model, and they just announced something interesting. The XAI GROK 2.5 model, which was our best model last year, is now open source. GROK 3 will be made open source in about 6 months. And as Sebastian Rashka put it, it's quite cool that the open source community gets the real full-size model that was used in production, as opposed to a light or some spin-off version of it. Somebody correct my math on this. Am I understanding this correctly? So these are H100 equivalents, right? So this is 200,000 H100 equivalents. Within 5 years, they're going to increase the equivalent compute 250x. Meanwhile, there's tons of other things that are coming out. GROK Finance, GROK 4.2, which is expected very, very soon, I think within the next couple of weeks, I believe. We also saw in the LM arenas a model called Sonic, which was a fast coding model. It seemed to think that it was part of XAI. So we're not sure. It's just rumors, take it with a grain of salt, but it does seem like they're testing some coding model that might be a mini, some sort of a fast coding model. But the next kind of a big thing that he's saying he's going to attempt to achieve is this. And this is kind of important to think about because it might give you a glimpse into where things are going. If you're trying to predict how software changes, how different companies in the AI space, how they sort of evolve, if you agree with Elon's vision, or even if you disagree, but this will give you a glimpse of where things are going. He's saying it's an easy prediction of where things are headed. Devices will just be edge nodes for AI inference as bandwidth limitations prevent everything being done server side. What does this mean? Well, in a nutshell, we won't have apps or websites or anything like that that's pre-made. Your phone will just generate everything you want in real time. We've seen some of this with diffusion models generating video games in real time. Google DeepMind's Genie 3 is kind of stunning. You upload whatever image you want and you're able to just enter that world and walk around. If you're a cat walking around the room, you can jump on the furniture. It's pretty mind-blowing how well it captures the world. We've seen video games that are beginning to be playable with these diffusion models, or most of them I think are diffusion models. The point being, no longer does some engineer or game developer or app developer needs to code everything up letter by letter, and the user just sort of uses the code that they wrote. The AI can dream into life in real time, whatever you want. It might be games, videos, whatever apps you want. There's a number of times where I needed some little piece of software that you do just some tiny little thing, and I was about to open Google and search for it, but I stopped myself. By the way, this has been happening more and more over the last, I guess, year and a half, is instead of searching for something, I'd say, can some LLM like Claude or GROK or Gemini or whatever GPT version we're on, can it just write that software for me in, 20 seconds that I can use right now instead of downloading something, potentially there being some free trial that's going to get me to some forced subscription or whatever. And I've been finding that very often, yes, you can just quickly create some script or some piece of software just by asking the chatbot to create for you. That's going to do that thing. As this thing gets better, why would you need apps? Why would you need pre-made apps that you have to download from some server somewhere when this thing can just generate custom tailored, artisanal crafted software for you? So when Elon says that it has a non-trivial chance of achieving AGI and that he has all the pieces in place, I understand that. Again, don't take this to mean that 100% it's AGI. Again, kind of undefined, and non-trivial chance doesn't mean guaranteed, right? But based on what I just showed you, do you think that it's possible that there's a non-trivial chance? What is a non-trivial chance? 1%, 5%? So I asked a few models what, that would mean. I mean, I have an idea. I just wanted to kind of verify it. And the answers that I got seem very plausible. So if we're talking something that's like an existential risk, 0.01 to 0.1 is already considered non-trivial. So, if you have a 0.1 chance of a nuclear power plant meltdown, that's not trivial, right? That chance is non-trivial. For ordinary life decisions, it's maybe like 1 to 5% is not trivial. If there's a 5% chance you get evicted or fired from your job, or there's some health issue, you're probably going to think about it, right? You're not going to just ignore it. So based on what we looked at with the scaling up of RL compute, would you expect that either XAI with Grok 5 or potentially maybe some of the other companies that have access to a lot of compute? Would you say that they have a non-trivial chance of achieving AGI, but whatever fuzzy metric you want to define by, as they continue scaling up that compute? I certainly would think so. Either that, or I would expect to see a wall, which again, we still haven't seen. I know a lot of people are pointing to GPT-5 as a wall. My take is if we see that RL scaling really work, then we have a lot of progress ahead of us. If it just for whatever reason doesn't work or we can't figure out how to do it, then yeah, we might be at a plateauing of progress for a little bit while we come up with the next big thing. But again, we're beginning to see hints of the next thing that's coming. So I doubt it's just a big old nothing burger. I think there's going to be for sure at least some progress that we're going to see that's going to be kind of wild. So I understand what he's saying here, and I agree with it. If you're reading it literally as it's written, that there's a non-trivial chance, yeah, I agree. He's not saying it's guaranteed. He's saying there's a chance. The thing that I don't understand that he's saying is this. He said AI is obviously going to one-shot the human limbic system. That said, I predict counterintuitively that it will increase the birth rate. Mark my words. Also, we're going to program it that way. I said, I'm very curious to know more about this. I kind of assumed robots and AI waifus would have the opposite effect, right? So being able to flirt with digital people, you might not need to go out there in the real world and interact with real people, therefore less babies. And no, I'm not going to break that one down. But there are some counterexamples here in the comments. Here's Alex Finn. He's saying 100% agreed. I have a friend who talks to Annie, so the GROK companion thing. But Alex is saying that his friend talks to Annie 18 hours a day, and now he's never been more confident talking to women. Already has multiple girlfriends, with at least 2 of them being pregnant. Thank you, Elon. He had me going there in the first part. But whatever the case is, I am curious what Elon means by this. If you have any idea, let me know in the comments. I don't think he's explained this quite yet, but I'd be curious to know. He's going to program it to make us copulate. But one thing I'm going to do here is maybe pat myself on the back just a little bit. Not with anything that he's saying here, just in general. The one thing that I think a lot of people were missing about Elon Musk and XAI and GROK as he was training up all the previous models, a lot of people would say, well, it's not quite as good as the other leading models. What they were missing in that whole equation is the speed, the face melting speed at which he was building all this. It's like being in a race that has already started. You have people that are already running the race. You have your people in the front of the pack and people trailing behind. You come to that race late. You start after that starter's pistol, right? And you start running. At some point, you blow past the people in the back and you start approaching the front, right? So let's say you're in 5th place. At that point, if somebody looks at that and goes, oh yeah, but he's in 5th place, what is he going to do? Hey, that's really missing the plot, isn't it? Like if somebody goes from not being in the race to right behind the leaders, what do you think is going to happen next? Right now, Grok 4 is sitting on top of the vending bench. So it's able to run a vending machine very successfully over a long period of time. It's either top or near the top in GPQA Diamond AIME 2025, #1 in SWE bench by just a hair. So in a nutshell, why he expects Grok to be at the top of the leaderboards, I understand. Why it's going to give us a fertility boost, I don't understand. But you know what? I'm not going to bet against him. But let me know what you think. I'm focusing more of my attention on reading a lot of the comments that watchers of the channel leave down below. In the past, I've welcomed all sorts of comments, from the nicest ones to complete troll, horrible statements. I've never really deleted any comments. After talking to some people in the space, what they recommended is that deleting some of the needlessly nasty comments does create a better atmosphere for smart discussions. So you're welcome to agree with me or disagree with me. That will never change. But if you're needlessly rude to myself, the people that we talk about, or anybody else in the comment section, really anybody, don't be needlessly rude to anybody. You can still disagree with them, but the super overline stuff, we're going to slowly start weeding out. If you haven't checked out the Wes and Dylan AI podcast, it's another YouTube channel here. We also stream across all the podcasting services like Spotify, etc., Apple, iTunes, all of that. We just interviewed Nick Bostrom. It's an incredible interview. We dove really deep. He mentions Elon specifically for some of the things that he's been doing in the AI space. You're never going to guess what it is. I'm 99% certain you'll never guess what it is. But check out that interview. I'll link it down below. Maybe it'll also pop up somewhere here on the screen. We also interviewed Adam Bigsmith from AI Village. So check that channel out. It's a little bit more serious, a little bit more along a format. Here I want it to be a little bit more fun, a little bit more engaging, a little bit off the cuff. There, it's a lot more structured. You'll notice the thumbnails are different and so are the titles. So a lot of you that do not enjoy my fun approach to thumbnails and titles might like this better. But whatever the case is, thank you so much for watching, and I will see you in the next one.